Was good. Welcome back, Algebra fam. So welcome back to How to Algebra. Today we're breaking down vertical transformations with a little extra: stretch, shrink, and reflection. When you multiply the function by a number greater than 1, the graph stretches vertically, making it taller or longer. If you multiply by a number between 0 and 1, i.e. 1/2, 1/4, 1/3, some kind of fraction between 0 and 1, it shrinks, flattens out, so it compresses. And if you multiply by a negative, the graph reflects over the x-axis, flipping it upside down. Combine all these things and you're transforming graphs like a pro. So let's get it. All right, vertical transformations. So here we have a function that is defined, right? We have a table here, it's defined, and we're going to look at a few different examples of different ways we can transform this bad boy. All right, so since I am using technology, I'm gonna cheat a little bit, and we're gonna be using this table to help us out. Okay, first off, we have f of x plus 2, right? All this plus 2 business is that it's gonna shift it up, right? It's gonna take the function and it's gonna add 2 to all the y values. So when you're adding 2 to all the y values, it's going to shift up, right? So just understand that when you see plus 2 outside of f of x. So right now we're doing vertical transformations and we're dealing with all things outside of f of x, right? This is f of x plus 2, right? This is a vertical shift up. Every point is going to shift up. So I don't necessarily, well, I'm not going to go through the table, right? Like, I don't need to explore, right? I already know. I'm just explaining. So I don't care about the table, either table, to be exact. I'll use the table when it becomes relevant. But every point is going to shift up too. So, for instance, this point is going to shift up too. I'll shift all these points up too. Like every point in the function is going to shift up too. All right, so connecting the dots, we get a vertical transformation. F of x shifts up 2 units. So I will write this next part. And that's because f of x plus 2, right? We're adding 2 to all the y values. All right, number 2, f of x minus 2. Well, if plus 2 shifts up, negative 2 minus 2 shifts down. So again, every point is going to shift down 2 units. So let's do that. All right, so again, it gets shift down 2 units. So you're just clicking and dragging down. It doesn't change the shape. It just slides it one way or the other. In this case, it shifts, and that's because of the minus 2. Okay, here comes a stretch. All right, so we have a number that's being multiplied to f of x, right? A factor of 2. That means the outputs are going to double, right? Whatever y is, I guess we could use the table here, right? Because it's the same in every picture, so it's going to be the same table. So just, I'm going to do like a couple for you. When x is negative 4, right? When x is negative 4, the input is negative 4. The output is going to be 3. That's naturally, that's how it's defined, right? At x equals negative 4, y is 3. That's that point right there. Now, what the transformation is going to do, it's going to multiply 3 times 2, which is going to be 6. So the new point is going to be negative 4, 6. Now, technically, I could go through and use all of these Do I want to? I mean, you don't really need the table, but you know, I guess since it's here, we'll use it. But we're multiplying 2 times all the f of x, like all the y columns, right? 2 times 0. Okay, and these are all our points. But let's pretend that we didn't know that. We'll use it to verify here in a second. So let's say we don't have a table, right? Tables for babies. So, right, when you're nice, we don't necessarily need a table. So we're just going to grab a couple points. Something to remember, that when we're just stretching or shrinking, the x-axis, where the graph crosses the x-axis, you're basically putting a pin in it, right? These points aren't going to change, right? Because at these points, the y value is 0, and 0 times anything is 0. So wherever we cross the y-axis, or correction, the x-axis, just put a pin in them. Right? Those points aren't moving. They're there. For show. All right. Here, this point, at x equals -2, y is 1, 2, 3, -3. So we're going to double that. We're going to make that -6. So that point's going to be down here. So far, our graph looks like this. Right? It's just stretching. All right, let's grab another point. Y equals 3. So that's going to get doubled to +6. At x equals 1. Y is 1. So that times 2 is 2. 1 times 2. We have when x is 2, y is 2. So 2 times 2 is going to be 4 because it's doubling. And then again, the x-axis stays. We have when x is 4, y is -2. So times 2 would be -4. All right, so the graph will look as follows. There it is. It is stretched by a factor of 2, like vertically stretched, factor of 2. Now, if we want, we can use the table to kind of verify what I'm saying. So if we pick a point, right, this would be, again, disregard the middle. I don't care about those anymore. So -4, 6, -4, 6. Yep. -3, 0. That's what I was talking about, right, on the x-axis. -2, -6. -1, 0. Right, all the points are there. So as you can see, you don't necessarily need a table as long as you understand what the transformation is doing to the function. You can just use the picture. Now, I'm not saying that you'll never have to use the table. The table is nice, but all right, it stretches vertically, or vertical stretch, by a factor of 2. So it's doubled. Okay, number 4. All right, so check it real quick, back up. So it stretches because the number is greater than 1, right? We're multiplying by a number greater than 1, right? A number greater than 1. That's why it's stretching, right? That's a stretch. All right, here we're multiplying by a number that is between 0 and 1, right? A number that's between 0 and 1. So 1/2 is definitely between 0 and 1. And this is going to be a shrink. Or, I guess, compression, right? Shrink is what I need to see. So it's a compression. All right, let's compress this thing. So without the table, by a factor of 1/2. So whatever it is, we're going to cut the y value in by 1/2. So this is 3. So we're going to go to 1.5. Again, where it crosses the x-axis, these points are not going to change. They're there. All right, so 1, 2, 3. So that'll be 1.5. 3 again. So 1.5. Here we have a 1. So that's going to be cut in half. We have 2. That's going to be cut in half to 1. And then -2 will be cut in half to -1. All right. I guess I could have made it bigger for you. Okay, so check it out. This is going to be, so it's like you're squeezing it, right? Squeezing it, you're compressing. So this is a vertical compression or shrink by a factor of 1/2. All right, number 5. When we have a negative outside, this is going to, all right, this is going to reflect across the x-axis. Now, the way that I like to think about it is, so you have your vertical, right? And this is how I think about it. So everything vertical outside of the f of x is an up and down motion, right? So it's going to shift up, shift down. It's going to stretch vertically. It's going to compress vertically this way. Not only that, but see if you can catch this visual. Look, I'm going to help you out. So it's going to rotate vertically. Right, so that's how I always think about it. If there's a negative outside of the f of x, anything outside the f of x, like if I'm multiplying by a number, if I'm adding a number to f of x, anything outside of the f of x is going to be vertical. So shift up, shift down, stretch, compress, and then rotate this way. So this is how I think about it. So that's how I remember it's the x-axis, because it's so easy to get confused and put it across the wrong axis. All right, so with that being said, every point is going to reflect across the x-axis. So let's see. So this point is going to end up 1, 2, 3. So 1, 2, 3. -3. The points on the x-axis remain the same. This point here, -3, will end up being +3. +3 here will end up being -3 down here. +1 is going to be -1. +2 will be -2. And then -2 will become +2. All right, so let's connect the dots. It's going to look like this. Threw me off for a second because this one's supposed to be black. What's going on? Okay, so all it did was kind of twirl across the x-axis. So that's what happens when a negative is being multiplied outside of the f of x. It's a reflection across the x-axis. So I guess we could put this down here. Right, it reflects across the x-axis. All right. Number 6, absolute value. All right, what absolute value is going to do, it's going to turn anything negative positive, right? Anything that's negative will be positive. So the y value, if the y value is negative, then it will be positive, right? Otherwise, it stays the same. Okay, so let's see. Let's start on the left. So when x is -3, right? And we're only concerned with the y's, right? The y's is what we're looking at. The absolute value of the y value, not the x value. So when x is -4, y is going to be +3. So that point is actually going to be on the new function. When x is -3, y is 0. Our absolute value of 0 is 0. When x is -2, y is -3. Therefore, x is going to be +3. When x is -1, y is 0, and absolute value of 0 is 0. Okay, when x is 0, y is 3, so absolute value of 3 is still 3, no change. Here, the y value is positive, still no change. Y value is positive, no change. Y value 0, absolute value of 0 is still 0. Then when x is equal to 4, y is equal to -2. Therefore, the absolute value of -2 is +2. So any part that is below the x-axis will just get flipped up. So the graph is going to look, all right, there it is. It gets reflected or flipped up. All the negative values become positive. So that's kind of interesting. All negative y values become positive. Okay, we're at the last one. So this is kind of a combination of everything that we just learned. So it's several at one time. All right, it is very much my recommendation that the transformations be applied in a very particular order. Right now, do you have to apply them in a particular order? No, you can apply them however you want, but just know that if you do go down that route, it's possible that you might get it wrong. So it's efficient if you reflect first if possible, then stretch if possible, and then shift. So reflect, stretch, shift. Reflect, stretch, shift. All right, that's the sequence that will optimize this, right? Like it almost guarantees that it's going to look right. Because if you do it out of order, it's not a guarantee that you're doing it correctly, is all I'm going to say. Now, that's probably debatable. So we're going to reflect, then we're going to stretch, and then we're going to shift. So check it out. So this is -2. So the negative reflects it across the x-axis. The 2 is going to double it, right? It's going to double, stretch it after it reflects. So it reflects, stretch, and then it's going to shift down, right? Because of the -1. So f of x. So it's going to reflect, it's going to stretch, and then it's going to shift down. So check it out. I mean, I guess we can make a table, but again, I don't need a table. So here we have a point. And remember, it's doing it to the y value, whatever the y value is. The y value right now is 3. So just kind of like note what's happening, right? This is 3. Technically, it's -4, 3. So we're looking at the y value. The y value is going to reflect down. So it's going to become, see if you can follow this, -3, right? Because it reflects it, -3. But then I got to multiply it by 2. So the -3 is going to become -6. Not only that, we're going to subtract 1. We're going to shift it down. So it's going to become -7. So just that first point alone, there it is. All right, the second point, y is 0. So 0, it's going to get reflected. So it's going to stay the same. And multiplied by 2. Cool. 0 times 2 is 0. And it's going to shift down 1. So that point is going to be here. Down 1. Okay. The next point. -3. So -3 is going to reflect up. So +3. Then times 2 because we're doubling. So 6. And then it's going to move down 1. So down 1. I'm going to erase the ones I don't want. Here we have +3. So +3 is going to reflect down. So -3. It's going to multiply by 2. So -6. And then move down 1. Do you have to put all these dots? No. I'm doing it for effect so you can kind of see what's going on. Okay. What else do we have? I kind of skipped over the point that, okay, so I did skip over a point. My fault. So at 0, we have another point at 0. X equals -1, y is equal to 0. Again, doesn't reflect because it stays there. Times 2, cool, it still stays there. But then it's going to shift down 1. Okay. Got like a couple more points. So here we have x is equal to 1. It's going to reflect down. Then it's going to stretch. So times 2. Then we're going to shift down 1 again. So finally, okay, when y is equal, or when x is equal to 2, y is equal to 2. So it's going to reflect down. So it's going to be -2. It's going to be multiplied by 2, so -4. And then it's going to shift down 1. Okay, the x-axis, that's a fun one, right? It stays no matter if I reflect or what. If I multiply, don't matter. And then finally, it's going to shift down 1. And then last but not least, we have y is equal to -2. It's going to reflect up. so positive 2. It's going to be multiplied by 2, so 4. And we're going to shift it down 1. So minus 1 would be 3. All right, so here are all of our dots. Let's connect the dots and see what this thing looks like. Hopefully I did it correctly. Okay, there it is. This is the function, right? The original function, the OG function was in black. The parent function, not parent function, but the original. And then we reflected it across the x-axis, so we spun it. Then we stretched it. So we spun it, stretched it, and shifted it down. All right. Do we have to write what we did? I feel like I just explained it. So hopefully you have a better understanding of vertical transformations. Feel free to pause the video and fill out the charts if you like, but that's it. Catch you guys in the next video.